All right, this instrument is the microwave temperature profiler, MTP, we call it. And we talked briefly about the machine shop and how they fabricate the fairings that surround our instruments. You know, an instrument sitting on a laboratory bench is a very irregular shape and not well suited for aerodynamic flow. And so they built this piece, this white piece, and that was certified by the FAA. All of our instruments on the wings fly in these gold canisters. They're all the same size, you'll notice. And so the electronics of my instrument slide back into that canister. And since it's already been certified and they know how much it weighs and everything, it can easily be mounted on the airplane. And this is another instrument that measures aerosols. It's called the UHSAS. I forget what all that stands for. But it's also in one of these canisters. So this instrument you'll see, so I have this aerodynamic fairing, and then there's this piece of plastic. This is transparent in the microwave frequency range where I do the measurement. And so there's a mirror in here, a flat mirror about this big around, and it rotates 360 degrees. And then it reflects the signal back into a receiver and separates out the frequencies. I measure 3 frequencies, and then records the data on a computer in the cabin.
So that mirror is automated?
Yeah, there's a stepper motor that's running it. And it stops at 10 positions above and below the airplane. So I'm sampling 80 degrees from the horizontal, and then 70 degrees. And it stops and takes a measurement. And then it scans backward, looks backwards, and I have a target there to do my calibration. And so that target is heated to a known temperature. I know the emissivity of that target, and so I know what it should be measuring, and so I can compare that to what it actually is measuring. And
so you're taking 3 wavelengths?
3 wavelengths, yeah.
And is that just to cross-calibrate, or is it
no, 3 wavelengths is because the 3 wavelengths are centered on frequency bands where oxygen emits. Okay, so it's a peak in the oxygen emission spectrum, but it emits at different levels. And so the radiation I receive at one frequency is coming from a further distance than it might be at another frequency. And so it gives me, I have 10 angles where I sample 10 points, 3 frequencies. So I've got 30 measurements out there ahead of the airplane. They're all at different altitudes and different distances from the airplane. And so then I'll fold them together with the next scan and figure out the geometry of where each point lines up. So when I do a vertical profile, all my points aren't necessarily from the same single scan because they're measured at different distances from the airplane.
And then the airplane is doing a vertical profile as well.
No, the airplane's flying.
Is that when it's just flying straight? Okay. Thank you.
Takeoff and landing to any of your instruments? Catch a bird or anything?
I have not.
Okay.
Yeah, I used to fly a microwave radiometer that was underneath our C-130, which is really low to the ground, and that always made me nervous. But we were lucky.
How often do you have to calibrate?
Well, it calibrates itself every scan.
Every scan?
Yeah, and then after a project, then I go back and do some overall calibration, post-analysis sort of thing.